Hello friends, welcome to the video tutorial of C programming, and in this video we are going to study one more function related to two-dimensional array, and the function is to add two matrices. Okay, so let us understand how to add a two matrices, and then after we will see the logic behind this. Let us consider this example. As you can see here, there are two matrices and both the matrices are of same order, means of 2 by 3 order. So remember one thing, whenever you are adding two matrices, the order of both the matrices should be same. Now what it means, your row size should match as well as your column size should match. Okay, if any one of these both is different, then you cannot add the matrix. Now let us see how to add it. Now definitely resultant matrix is also of order 2 by 3. So here what happened, the element at 0th position, which is 3 here, and here it is 1. So element at 0th position get added with 0th position, and result is also placed at 0th position. Similarly, now these two elements get added, this 2 and 6. So element at 0, 1 position and the element at 0, 1 position of second matrix get added and placed at 0, 0, 0, 1 position. Similarly, 7 and 2 get added, placed at 0, 2. 1 and 3 get added, placed at 1, 0. Then 4 and 3 get added, will be placed at 1, 1, which is 7. And here element at 1, 2 position get added, which is 6 and 3, and placed at 1, 2 position. Okay, so quite easy, right? So addition of two matrices is quite easy. You have to just take an element at ijth position from first matrix, assume that first matrix is M1, then add it to second matrix ijth position, and whatever result you will get, you will also place that result at ijth position. Okay, so here value of row index and column index for all the three matrices is what? Same. So that's why this coding is going to be easy. Just what care we have to take? We have to check whether our row size of both the matrices and column size of both the matrices will match or not. If it is different, you cannot add the matrix. Means if you have one matrix of order 2 by 2 and another one is of order 3 by 3, you can't add. Remember this thing, you can't add. Now let us see the function related to this. Let me switch to next page. Okay, now here let us call my function as add. We'll define the return type later. Now to this add function, definitely I have to pass two matrices or two-dimensional array. So let us say int, say M1. So here also I am declaring my array of maximum size and will only process row by column element. Now second array is passed. Okay, now here as we know, we cannot return the array. Why? Because function can return a single value and array is a collection of more than one value. So we cannot return the array. So that's why we are going to keep return type void, and whatever will be our resultant array, it is also passed as an argument. So initially this array is going to be empty, or it will have garbage data, whereas M1 and M2 will have some data in it because we want to process that. And after the processing of this, we will put a result in this M3 array. Okay, and after the function execution, M3 will have a valid data. Now here we have to pass few more extra parameter, that is row size and column size of first matrix and row size and column size of second matrix, because as you can see here, we declared our array of maximum size and we only want to process row by column element. So let me define that parameter also. So int r1 and int c1. So these are the row size and column size of first matrix, and int R2 int C2. This is row size and column size of second matrix. So as I told you, first of all, what we have to do, we have to check whether R1 and R2 same and C1 and C2 are same. If it is same, then only we are going to add it, otherwise not. Okay, so let me put a condition. If R1 is not equal to R2, I'll put a opposite condition, means instead of equality I'll put non-equality condition, or now in this case I have to use or C1 is not equal to C2. If R1 or C2, if both the rows or both the columns are different, in that case I do not want to perform anything. In that case I'll say just return. See, we can use return statement, remember this thing, but without any value, because what is our return type? Our return type is what? Void. Now if my row size and column size are what? Same, in that case I can perform the addition. So here I'll not put a else part, because see, remember this thing, if this condition satisfies, your program will return from here. The statement below this return statement will not get executed. Okay, and if this condition is false, it automatically came down. Okay, now here we have to perform the addition row column wise, and for that we need to represent our index value. So let me declare that variable. So I and j, only two variables are required, because as I told you, here the element at corresponding position get added and stored at that same position, means ij element at ij position get added with element at ij position and stored at ij position, means the index value of all the three matrices is what? Same. So we do not have to use three different variables. Okay, so only two variables are required, I and j. So let me write a loop for I is equal to 0, I less than R1, I plus plus. Now remember one thing, here you can use either R1 or R2 or C1 or C2, because when we are proceeding, when both the values are what? Same. If it is different, it will never enter in this area. So you can use R1 or R2, it do not matter. Now for j equal to 0, j less than C1 and j plus plus. Now here we have to write the addition statement. So M3 of ij is equal to M1 of ij plus M2 of ij. That's it. So your I value range from 0 to R1, j value range from 0 to C1, and so on. And I hope you already know the working of nested loop. So if you are not familiar of that part, I already uploaded the videos of nested loop. So if you are not familiar, please watch that videos. Okay, now as I told you, my function is also complete. As I told you initially, our this M3 array is going to be empty. Okay, after this addition, your M3 array will have some valid data. Okay, now here as you can see, this particular portion, okay, this particular portion, what we wrote here, if my row size and column size, any one of these two, if it is different, then I am not returning anything. In that case, my M3 array will have a garbage value, or you can say it is empty. Okay, so how this came to know to your calling program that you did an addition successfully or not? Because here you are just saying return. Okay, and M3 will have either valid data or garbage value, and the calling program cannot determine it, right? So instead of returning the void value or void data, what will I say? I'll say return int. What will I say? I'll say return int. And here what will I do? I'll say return 0. Here I'll say return 0, means if this condition satisfies. Means if R1 or R2s are different, R1 and rows and columns are different, in that case I'll return 0, means addition is not done successfully. And if this condition fails, that means addition is done successfully, and here I'll say return what? 1. Means it is nothing but we are saying return what? False. And here we are saying return what? True. Okay. And again same rule is applicable for two-dimensional array also. Whatever changes you will make in your array, in your function, it get reflected in your calling program. Okay. Remember this thing. Whatever changes you will make in your array, in a function, it get reflected in your calling program. Why? Because arrays are passed by reference by default. Okay. So always remember this thing. Again I'll repeat, whatever changes will be made by function in an array, it get reflected in a calling program, because arrays are passed by reference by default. Normal variables are passed by value, whereas arrays are passed by reference. So here after this execution of this add function, M3 array will have some valid data if this condition fails. Okay, means if R1 and R2 and C1 and C2 are same, then this particular part executed and you will have a result of addition in your M3 array. Now let us execute this program in code block. Now please look at this program carefully. Okay, so as you can see here, I already completed the program, but here I included the various functions in it. Okay, I just do not add the add function. I also added accept and display function. Okay, so what this accept function will do, it will accept the value for a matrix. Okay, because if you consider this program of matrix addition, you have to take an input for the two matrices. Okay, and then after you want to display original matrices, suppose assume that you want to print the original matrix, means input matrix also, and then you want to print the resultant matrix. So in that case also you have to write 3 different loops. So instead of doing that task again and again, what we can do, we can write a function. So this accept function will have this M array, and we also pass row and column value. So what this function does, it will accept R by C elements and it will store in your M array. And again, according to the what you can say characteristic of a array, whatever changes made in function in array, it get reflected in the calling program. Similarly, here I wrote a display function also, okay, which is just printing the M array and its R by C values, means R column and R rows and C columns. So while printing, just you have to take one more care that after completion of your inner loop, don't forget to print new line, so to get an effect of that matrix. Okay, and here I am displaying my output in 3 spaces for just a proper alignment. Now let us observe the definition of add function. Now look at here, it is accepting 3 arrays. Okay, first 2, M1 is input matrix, M2 is input matrix, M3 is resultant matrix or addition matrix. This R1 and C1 are nothing but a row and column of first matrix, that is M1, and R2 and C2 are the columns, row and columns of second matrix. Now here also we declare the index variables required locally for a particular function, and then we check for this condition. If R1 not equal to R2 or C1 not equal to C2. If any one of these two values are not equal to, then we are returning 0, just to indicate the calling function that addition is not successful. Otherwise, if this condition do not satisfy, it will directly jump here and according to our addition logic I just put that code, and after that I say return 1. You can exclude the parenthesis for your return value, or you can include it, do not matters, both the syntaxes are valid. Now look at here, your main program is quite easy and it is less complex. What we did here we just declare the 3 arrays of maximum size, right, of 30 by 30 A, B, C, as well as we declared row and columns of both the matrices. Okay, then I declare the flag variable. I will tell you the purpose of this. Now here I scan the row and column of a first matrix, and before that I just give a message that enter row and column of first matrix. And look at here, I collected it in row 1 and column 1. And the important thing is that I give call to the accept function that we define at the beginning. Okay, so instead of writing this logic in main function, okay, I just give call to that accept function. So I'm just going to reuse that part. So my main program will be less complex and it will be easy to read. Similarly, here we scan the row and column of second matrix. Okay, and we kept it in row 2 and column 2, and again I give call to the accept function. So accept function is reused, right? So this time I passed B array and row 2 and column 2, that is row size and column size of a second matrix. Now here we give call to the add function where we pass 2 input matrices and third one is resultant matrix, that is C. And then after we pass a row size and column size of both the matrices, that is A and B. And as we decided that our add function will return true and false value. Okay, so I have to collect it. So for that I declared that flag variable, and it will be of type integer because we are returning what, 0 and 1. Okay, then after I'll check the value of flag. So remember one thing, here I didn't say flag is equal to 1. I just say what, if flag, see, if value of flag is 1, it itself evaluated as true, and if value of flag is 0, it itself evaluated as false. So it is not necessary to add an extra condition part. Okay, now if this flag value is 1, then addition is done successfully. So we give call to the display function. Okay, and what we want to display, we want to display a resultant matrix. But what is the row size and column size resultant matrix? It can be row 1 or row 2 or column 1 or column 2. You can pass either value, because when addition will be done, when your row 1 and row 2 are same and column 1 and column 2 are same, so you can specify any one of these two values. If flag value is 0, that is we can't perform addition, the order of both the matrices are different, so we just display the message that can't add. Okay, now here what will I do, I'll just display both the input matrices also, means A and B also. So here I'll say display A comma row 1 comma col 1, and then I'll say display. So all the 3 matrices get printed. Now just observe the advantage of function. Okay, once you write it, you can reuse it as many times as you want. Okay, let us execute this. Now here I'll enter row and column size of first matrix as 2 by 3, means 2 rows and 3 columns. So let me enter the value 1, 2, 3, 4, 5, 6. So these are the elements of the first matrix. Now let me enter the same order, that is 2 rows and 3 columns. Now here I'll say 11, 22, 33, 44, 55, 66. Okay, now look at here, this is your first matrix, that is 1, 2, 3, 4, 5, 6. This is your second matrix, 11, 22, 33 and so on, and this is your resultant matrix. Before this you can print the message also. So 11 plus 1 is 12, 22 plus 2 is 24, 33 plus 3 is 36, Okay, so just print the message, so you'll get a means proper, it will be more readable and more understandable. Okay, now let us try for invalid or different order for both the matrices. So as I told you, here you can print the message printf first matrix, okay, /n. Then here also you can say printf second matrix, and then you will say printf a resultant matrix. Okay, so let us run this again. Now here I purposely entered both the matrix of different order, so I'll just enter the order of first matrix as 2 by 1. Okay, so I have to enter just 2 elements only. Now I enter the order of second matrix as 1 by 2. So here my row and column sizes are different. It will show you message that can't add. Okay, similarly you can try it for the different values, and let me know if you have any doubts. So definitely you can write it into the comment box. Thank you.